Hi and welcome back to freesciencelessons.co.uk. In this video we're going to look at elements in Group 1, which is also called the alkali metals. By the end of this video you should be able to describe the properties of Group 1 elements. You should then be able to describe how Group 1 elements react with non-metals including water, and finally you should be able to describe and explain the trend in reactivity going down Group 1. So here's Group 1 in the periodic table. The first key point that you have to remember is that Group 1 elements all have one electron in their outer energy level, and this explains why they all react in a similar way. So we're going to start by looking at the properties of Group 1 elements, and we're going to start with density. Firstly, all Group 1 elements are low-density metals, and I'm showing you sodium here. In fact, the Group 1 metals are so light that the first three, which are lithium, sodium and potassium, will actually float on water. Let's move on now to look at the melting and boiling points. As you move down Group 1, the melting and boiling points of the elements go down. In fact, cesium has such a low melting point that it can melt on warm days. Okay, so we've looked at the properties, so let's see how Group 1 metals react. Firstly, we're going to look at how they react in terms of electrons, and then we're going to look at their reactions with water, which you need to learn. Remember that all Group 1 elements have got one electron in their outer energy level. I'm showing you lithium here, but the idea is the same for all the Group 1 metals. You can see that lithium has 3 positive protons in its nucleus and 3 negative electrons in their energy levels. This means that the atom has no overall charge. I'm going to react this lithium atom with a non-metal fluorine, but again this would apply to any non-metal atom. So here's the fluorine. When Group 1 metals react with non-metals, they lose the 1 electron in their outer energy level, and they pass this electron to the non-metal atom like this. You can see now that the lithium still has its 3 protons in the nucleus, but now it only has 2 electrons. This means that the charges on the lithium are now unbalanced. There is 1 more positive charge than there are negative charges. So the lithium now has 1 overall positive charge. We call this the lithium ion, and here it is. Remember that when all the Group 1 metals react with non-metals, they lose their 1 outer electron and form ions with a single positive charge. So in other words, elements in Group 1 form ionic compounds when they react. I'm showing you some Group 1 compounds here, and you can see that all compounds of Group 1 metals are white solids. And when we dissolve Group 1 compounds in water, they form colourless solutions, and you do need to learn that. Let's take a look now at how the Group 1 metals react with water. It's really important that you learn this since it's frequently on exams. Here's the reaction for lithium and water. Here's the equation for sodium and water. And here's the equation for potassium and water. The first thing that you need to learn is that all Group 1 metals react with water to produce hydrogen, and there it is. They also form compounds called hydroxides, and here they are. These all dissolve in water to form alkaline solutions, and this is why Group 1 is called the alkali metals. Now, one key idea that you have to understand is that the Group 1 metals get more reactive as you move down the group, and I can show you that with the reactions with water. Here's lithium reacting with water, and you can see that it's a fast reaction. Here's sodium reacting with water, and this reacts faster than lithium. And finally, potassium reacts faster than lithium or sodium. So we can see that the Group 1 metals get more reactive as you move down the group, and you need to be able to explain why in terms of electrons. Remember that all Group 1 metals lose their outer energy electron when they react. The key idea that you have to get is that it gets easier for the Group 1 metals to lose the outer electron as you move down the group. Let's see why. Here's lithium again, and here's the outer electron that gets lost when lithium reacts. Remember that electrons are attracted to the nucleus because electrons are negative and the nucleus is positive. Here's sodium, and remember that sodium reacts faster than lithium. That's because the outer electron in sodium is less attracted to the nucleus. There are 2 reasons for this. Firstly, the outer electron in sodium is further from the nucleus than the one in lithium, so it experiences a lower attraction. Secondly, the outer electron in sodium is shielded from the positive charge of the nucleus by the extra electrons, which I've shown in red. Remember that these electrons are also negative. So both of these factors mean that the outer electron in sodium is easier to lose than the outer electron in lithium. and this explains why sodium reacts faster than lithium. Finally, if we look at potassium, we can see that the outer electron is even further from the nucleus, and there are even more electrons to carry out shielding. So the outer electron in potassium is even easier to lose, and potassium reacts very rapidly indeed. Okay, so hopefully now you can describe the properties of group 1 elements. You should then be able to describe how group 1 elements react with non-metals including water. And finally, you should be able to describe and explain the trend in reactivity going down group 1.